Hi everyone! In this video, we are going to discuss Chapter 3, which is Application of Differentiation. The topics here is related rates. Okay. In this section, we are going to look at an application of implicit differentiation and an application of chain rule. In differential calculus, related rate problems involve finding a rate at which a quantity changes by relating that quantity to other quantity whose rate of change are known. Right? The rate of change is usually with respect to time. Right? Alright, now let's look at the procedure to solve related rates problems. The most common way to approach related rates problem is the following. From the given question, first step, draw an appropriate diagram and label the quantities relevant to the problem. Step 2, put a suitable variable based on the given units. And step 3, write the information into a mathematical expression. And when we begin the solution, we continue with step 4. Write an appropriate formula based on the given shape. Step 5. Differentiate both sides implicitly with respect to time, or we can use chain rule. Step 6. Replace the given value into the appropriate variable. And step 7. Solve for the wanted rate of change and put a suitable unit for the final answer. Alright? For this related rates problem, it's usually best to just jump right into some problems and we see how they work. Alright, now look at example 1a, spherical shape. Right? A soap bubble retains its spherical shape as it expands. If air is blown into it at the rate of 6 cm³ per second, how fast does its radius increase when the radius is 4 cm? Alright? Okay, from the given question, first step, we draw an appropriate diagram and label the quantity relevant to the problem. Alright? So this is our diagram, okay? Spherical shape, okay? With radius r. And then put a suitable variable based on the given unit, right? The given unit is cm³ per second. Okay, cm³ means volume. Per second means per time. Okay, and the word used is blown. So means that the volume will increase. So we can write variable dv for volume over dt over time equals to positive here because when air is blown means that the volume will increase. So we put plus sign here. Okay, actually for positive sign we don't need to write, but for negative sign we must write. Alright, and then here positive 6 cm³ per second. The variable is d volume over d time. Alright, based on the given unit. cm³ means volume, over second means time. Alright. And then step 3, write the information into mathematical expression. Right? Okay, how fast is the radius? Okay. Okay, means that dr over dt. Okay. How fast does its radius? So how fast means based on time, radius means dr. Okay. How? So means question mark. Right? And then when radius equals to 4 cm. Okay, we can write here. Okay, so this is the question we write into mathematical expression. Right? And after that, we begin with the solution. Okay, we continue with step 4. write an appropriate formula based on the given shape. Okay, the given shape is sphere. Okay, and we have information about volume, means volume of sphere. So we start with formula volume of sphere, which is 4/3 pi r cubed. Alright. And after that, step 5, differentiate both sides implicitly with respect to time, or we can use chain rule. Let's say we use implicit differentiation. Okay, so we differentiate volume with respect to time. So we have dv over dt, and then we differentiate pi over 4/3 pi r cubed. 4/3 pi is constant, so we differentiate r cubed here, so we can move power to the front and we can simplify with denominator 3 here. So we have 4 pi r squared. Okay, reduce 1 from the power, and then we differentiate variable r with respect to time. So we have dr over dt at the back. Alright. And then step 6, replace the given value into the appropriate variable. Alright. Okay. Now we have dv over dt equals to 6. So we replace 6 into dv over dt. Okay. And we have r equals to 4. So we replace r equals to 4 here. Alright. We replace the given value after we differentiate both sides implicitly. Alright. Never substitute the value of the given variable earlier. Means never replace the value of r and the value of v into the volume formula before we differentiate. Okay, make sure we substitute the given value after we differentiate. Alright. Okay, after that, step 7, solve for the wanted rate of change and put a suitable unit for the final answer. Okay, so now the wanted rate is dr over dt. Okay, so we write dr over dt as a subject. So we have 6/64 pi here. And when we simplify, we have dr over dt equals to 0.0298. Okay. And after that, we must put a suitable unit. From radius, okay, radius is cm. Okay, so we must put cm over time here is second. So over s for second. Alright. So therefore, the radius is increasing at a rate of 0.0298 cm per second. The word increasing here because the symbol for the final answer is positive. Alright, so means that the radius is increasing. Alright. Alright, now look at the same example, but this time we use chain rule to differentiate. So we continue from step 4. Okay, from step 4 we have volume of sphere. Okay, which is 4/3 pi r cubed. Alright. Okay, when we differentiate using chain rule, okay, we find dv dr first. Okay, so from here, okay, when we differentiate dv over dr, so we have 4 pi r squared. Okay, at the back actually we have dr over dr, but we can simplify dr over dr equals to 1. Right, so we have dv over dr equals to 4 pi r squared. We differentiate with respect to r. Alright. And after that, we create chain rule formula. Okay. The question is find dr over dt. Okay. So under chain rule, we write dr over dt as a subject. Alright. And we have two variables v and r. So we have two multiplication of derivative. Alright. When we use chain rule to find dr dt, the first numerator should be dr and the last denominator should be dt. Okay. Alright. And then in between is dv. Okay. Okay, after that, dr over dt equals to, okay, we have dv over dr. But in this formula, we have dr over dv. So we need to use reciprocal value here. So to find dr over dv, we need to write 1 over 4 pi r squared. And then times dv dt, okay, we replace by 6 here. Alright. Okay. And then replace the given value into the appropriate variable. Alright. And solve for the wanted rate of change and put the suitable units for the final answer. Alright. And after that, we substitute r equals to 4 here. Okay. And then we substitute 6 into dv over dt. Okay. We substitute r equals to 4 here. And then we solve, so we have 0.0298. Okay, and then put a suitable unit. Okay, the unit for dr over dt is cm over second because r is given in cm and time is given in second. Right? So we have positive value here. So therefore, the radius is increasing at a rate of 0.0298 cm per second. Right? Coming up next, spherical shape example. Thank you for watching. Stay tuned. Bye. Assalamualaikum.